In this lecture, we'll study arithmetic progression. It's also called as AP, and it's a very common question in LCAT. To solve this, you only need two formula and one trick. That's all. So, what is arithmetic progression? It's just a sequence of numbers with some relationship to them. For example, 1, 3, 5, 7, and so on until it reaches 20. You can see that there is a difference of 2 in each entry. For example, if you add 2 into 1, you get 3. Similarly, 3 plus 2 is equal to 5, and 5 plus 2 is equal to 7. Moreover, there are 10 terms in this sequence, and the last one should be 19. Because 20 is not possible with addition of 2 units in each step. In order to find the nth term of the sequence, where and please note that in the AP, the difference will be constant along the sequence. For example, uh, if you calculate 3 minus 1 or 5 minus 3 or 7 minus 5, you would always get the same difference, which is 2. That's why, in order to derive a formula for nth term, we just have to take any of the two consecutive terms, find the difference, and that would be the key here. Also note that you should write down the latest term first and then the previous term. For example, here you cannot do 1 minus 3 because 1 is, the first term and 3 is the second term. You have to write the second term first and then the first term. Otherwise, the answer would be different. Therefore, for this particular sequence, that D is 2 and 8% the first term, which is 1. So 1 plus n minus 1 times 2. You can simplify it if you like. So just 2n minus 1. So often these sort of questions do appear in MCQs where you have to choose the right option from the choices. So that's how you solve them. The next question involves finding the sum of the entries in the sequence. For example, sequence is, and you would like to find the sum of first 5 entries. We would represent it with x and 5, and you can just add the entries together and you get the answer, which is 16 plus 5, 21, 24, 25. Now this method is inefficient because I asked you to find the sum of first 100 entries, it could take a lot of time. Therefore, we have our second formula of this lecture, that is Sn equal. Now we use this formula for our sequence. The difference was 2 after simplification. 4 times 2 is 8. And you get the same answer. In the last, I have a quick trick for you, or you can say a hack. If you have been given a log sequence which with a constant difference, and they ask you to find, for example, t, and instead of using that formula, you can simply do it likely. Way, like you can solve it as first term plus the number of steps it needed to reach the 15th entry times the difference. It looks like same with the formula, but mentally it's saved a lot of effort. So you just have to pass down one. There are 14 steps to reach the 15th entry, and the difference is just 3. Oh, yeah, so 14 parts 3 is 48 times 2 is 28. 28 plus 4 is 32, plus 10 is 42. So 42 plus 1 is 42. That's how they can solve it by